Average rate of change function describes the average rate at which one quantity is changing with respect to something else changing. Um, if I look at problem 12, my model is given as x squared plus 3x, and I want the change between -2 and 4. And the rate of change formula is if I have 2 points, then the output change to the change of the values. Let's say I would like, in the given order you want to go with, let's say you want to go with point A and point B. Then your denominator will be B, subtraction, and A happen to be a negative number. So your denominator will be two negatives kill each other, 4 plus 2, 6. Let's just do step by step. And this is 4 plus 2. And my numerator will be f of b is in this problem is 4. So wherever I see x, you substitute 4. 4 squared plus 3 times 4. 16 plus 12, which is 28. So f of b is 28, and I have another subtraction. Now I want to find out f of a. A is in this problem -2. F of -2 is -2 quantity square 3 times -2. -2 times -2 is a positive 4. Opposite signs multiplication is -6, which gives me -2. So -2. Then 28 plus 2, my answer will be 30 plus over 6, 5. What if I said for my points 4 and -2, calling 4 and A, B, and rate of change, average rate of change, is now my denominator is B minus A. B minus A is 4. Okay, now what I want to find in my numerator is f of b, and my model is x squared plus 3x. So f of b, sorry, f of my b is in this problem -2. F of -2, -2 squared plus 3 times -2, 4, -2. So -2 comes here, and I have a subtraction. Now I'm going to find f of a, and a in this problem is 4. 4 squared plus 3 times 4, 16 plus 12 gives me 28. So when I combine the numerator, -30, -6, two negatives kill each other, 5. So you end up with the same answer. Problem 20. Atmospheric levels of carbon dioxide has risen from 336 to in 1979 to 396. So 336 ppm in 1979 and 396 ppm in 2014. Find the average rate of change between these two dates. All right. So average rate of change. Again, my formula was f of b minus f of a, b minus a. So if I call 1979a 2014b, then 336 is your f of a, that's the output in that year, and 396 is your f of b, the output in 2014. So 396 minus 336, 2014, 1979. The answer I'm going to find here is 60 over 35, which is 1.714. If you had labeled it differently, let's say I called B 1979 and A, here B is 1979 and A is 2014. So 336 is f of B, 396 is f of A. Then average rate of change would have been 336 minus f of A and 1979 minus 2014, and the answer was going to be negative 60 over negative 35, 1.714. Two negatives kill each other. So your interpretation will be then carbon dioxide levels have risen at an average rate of 1.714 ppm per year. And where does per year comes in? Right here. This is over 1. So my average rate of change in this problem is change in ppm to change in time. And my time is in years, right? So then this here, my final here is 1.714 ppm per 1 year as a unit. Global temperatures may increase by up to 10 between 1990 and 1990 and 2100. So whatever the value here is increased by 10 in 2010. So for this problem, average rate of change is going to be, if I call 2100B and A, so this will be f of B and f of A. So f of B minus f of A, that is my formula, will be 10 given in this problem, because whatever the value here, let's say it is 10, now it is 20. Because the change is up to 10 Fahrenheit. Let's say this is 15, then this will be 25, 10 more. So f of b minus f of a is the difference. Then it's just 10. and divided by b minus a, 2100, 1990. So 10 divided by 110 years. So unit for the denominator is years. Unit for numerator is degrees Fahrenheit. So 0.0909 Fahrenheit per year. Because when I divide these two, I end up 0.0909, and there's, here you go, my invisible 1, which is produces per year, per 1 year. And so my unit for numerator will be still Fahrenheit and year. And problem 23, let's look at one more problem. In 2007, I have 40 songs. In your favorite iTunes. In 2010, I have 120 songs. In 2014, I have 40 songs. What is the average rate of change per year in the number of songs in your favorite iTunes playlist? For A, I'm looking between 2007 and 2010. So in the denominator, if I go B minus A, 2010, 2007. In 2010, my function output is 120. In 2007, my function output is 40. So my answer is going to be 80 over 3. So the average rate of change is 80. Oh, sorry. You can say 80 over 3 songs per year. Where did this come from? The units. What I did is instead of dividing this time, you can divide it too. Let me see my calculators. I looked at it this way. 80 songs and 3 year. That's your, so you could have said 80 songs per 3 year. Or you can say, take 80 over 3. This is over 1, correct? You can say 80 over 3 songs per year. Now I have per year, 1 year. Because I do this way, because if I divide 80 and 3, it gives me approximately 26.7 songs per year. Because I can't have a 0.7 song, obviously, then you might have said 26. But if you leave as a fraction, that is the best answer if the ratio of two numbers is not a whole number, because 80 over 3 is not a whole number, like 20 songs, 25 songs, 5 songs, so forth. Hope this helps. I'll see you next video. Thank you.